Okay guys, we're in the home stretch. You notice that as soon as we started to solve for some things really began to kind of come together. As soon as we were able to get F32y, it cascades through the rest of the solution for both the connecting rod and for the piston at the top of the page. So the crank then really becomes quite simple in comparison to the con rod. The con rod is the key to doing this kind of issue. Let's go ahead and continue on with it then. The crank will have its own force balance, and again we draw everything in a positive direction and note everything in the positive direction. It helps to keep us organized and helps to ensure we know which way those acceleration and forces are actually going. So we will have a force coming from the con rod acting on the crank, F21x and F21y. We will have forces acting at the bearing, same kind of thing, F01x, F01y, and we will have inertial forces acting at the center of gravity. I shouldn't call that F yet, negative M1AG1x, negative M1AG1y. We will have an inertial component, negative IG1 alpha 1, and of course we're going to have some kind of an applied torque. That was the whole point of this problem. So get an applied torque. And just like with the other free body diagrams, we can do a force balance equation for each direction and for the torque. Our first one then will be in the x direction, F01x plus F21x plus negative M1AG1x equal to 0. You may recall that in the setup of the problem we said, neglect the external loads and the inertia of crank 1. So, hooray. We're going to ignore that inertia. We've already figured out what F12x is equal to back up here in the con rod. So it's fairly easy for us to say then that F21x, negative F21x, is equal to F01x, which is equal to negative 144 newtons. In the y-axis, F01y plus F21y plus negative M1AG1y is equal to 0. And we're neglecting inertial forces for the crank. Hooray! So that implies to us that F01y is equal to 12.3 newtons. Now we get to the final meat of this entire problem, and that's the torque balance for the crank, because that's the main thing that we were asked to solve for, the input torque. I'm going to do that one in the next video file, so hold on, we just take a quick break.